Hi, welcome back to the time series analysis of COVID-19 data. My name is Jeff Washburn, and let's take a look at the COVID-19 analysis, shall we? First, let's understand what we're dealing with. COVID-19 is a worldwide pandemic that is greatly affecting the United States and the great state of Nebraska. The purpose of this analysis is to understand the progression that COVID-19 is making across the United States with a focus on the state of Nebraska. To do so, I'll be analyzing and forecasting the positive percentage throughout this presentation. I performed both univariate and multivariate models on the US and Nebraska with a total of 18 models that were created, 9 analyzing the US and 9 analyzing the Nebraska state data. Again, the United States data was ascertained from the Atlantic, the COVID-19 tracking project, which has about 6 months of daily data. The Nebraska state data is from the Nebraska's Department of Health and Human Services, which has about 4 months of daily data. And to remind the audience, the response variable has been defined as the number of daily deaths divided by the number of daily positive test cases. Looking at the United States data first, we see a positive percentage mean of 3.15%. Taking a look at the positive percentage realization, can see from the sample autocorrelations that the data somewhat wanders and has a slowly dampening ACF, which is an indication of non-stationary data. For the first model, difference the data, looking at the autocorrelations of the difference data, and it appears to be stationary. AIC-BIC indicated fitting an ARMA 5.2 model. The estimated ARIMA 5.12 model is shown here in red. The short-term forecast of 7 days looks quite nice, further supported by a low rolling window ASC of 1.38. The 90-day rolling window ASC does increase to 13.64, but still not too bad. For the second model, wanted to look at what a trend would look like for a forecast, so I fit a signal plus noise model. So the first thing, I fit the regression line against the positive percent as seen in the graph in the top left. The residuals appear to have no slope and further supported by running a Cochrane-Orchid test. However, the residuals are still correlated as shown by the graph in the top right. So fit an ARMA 4.3 with the final estimated model below in red. The short-term 7-day forecast has a pretty good rolling window ASC of 4.22, with the 90-day long-term forecast has a rolling window ASC of 95.84. That wraps up the United States data, and moving on to the Nebraska state data. The positive percentage rate for Nebraska is 1.49, so about half of what we saw for the United States. And again, looking at the overall data, we get an idea on the positive percentage value in blue. What's interesting about the sample autocorrelations is that it looks very close to white noise. Approach on this data was to look at the ARMA and ARIMA models. For the first model, AIC-BIC did pick an AR1, so went with that. After fitting the AR1 model, the residuals showed strong evidence of white noise, further backed by a 0.88 for the Young Fox test. And below in red is the estimated AR1 model. So the short-term 7-day forecast has a pretty decent rolling window ASC of 2.79, and I'd say somewhat impressive long-term 90-day forecast with the rolling window ASC of 3.35. As noted before, there seem to be some peaks on the spectral density, so used a factor table for a 1 minus b to the 7th and used an overfit table with the data to compare. Both AIC-BIC picked an AR7, and the residuals afterward showed strong evidence of white noise. The estimated ARIMA model below in red. The short-term 7-day forecast has a rolling window ASC of 2.87, which isn't too bad, and the long-term 90-day forecast has a rolling window average of 5.49. To look into the US and Nebraska data further, I looked at 4 different multivariate models. We have an MLR with correlated errors, the vector AR, an MLP, and an ensemble of the MLR and MLP models. The MLR model found that there was a 6-day lag between hospitalizations and the positive percent. I like the variable and can see that the forecast in the charts. The short-term and long-term ASCs were okay, but I'll cover those at the end. The multiple regression with correlated errors did not take into account the possible correlation structure within and among the independent variables, so combined hospitalized, positive, and death increase. I combined those variables for the VAR and can see the long-term forecast looks pretty good. Moving on to the MLP model, I chose the default parameters and combined the correlated variables from before using XREG. I combined using the mean. The corresponding MLP model has 12 input and 5 hidden layers, along with 1 output. Lastly, I created an ensemble model between the MLP and MLR for both US and Nebraska. The US model was able to provide both short and long-term predictions, but not very useful for the long term. I combined using an average of the predictions and then calculated the ASC. So looking at all of the models for the United States, the ARIMA 512 seemed to perform the best and would recommend this model for forecasting both short and long term for the United States. There's a total of 9 models that were created, so 5 of those being the univariate analysis, and the remainder 4 of those being the multivariate analysis. The short-term and long-term ASCs are provided in the table below, so as you can see that the univariate analysis seemed to perform quite nicely. I was quite happy and pleased with that. Moving on to Nebraska, so looking at all the models for Nebraska, again, there's 9 in total. Even though the AR1 has a lower ASE score for both short and long-term forecasting, and taking into account the multivariate analysis that was done, I'd still recommend going with the ARIMA as it seems to follow the data much better and the scores are quite impressive. Moving forward, I'd want to continue to collect the data on a daily basis and refine the models as much as possible to make them even more useful. The multivariate models would require a bit more work to make them more useful. Overall, I found the univariate models quite useful with better ASE scores than the multivariate models. Thank you for your time today. Appreciate you listening to my analysis on the COVID-19 data. If you have any questions, please reach out to me and happy to discuss with you further. Thank you.